Hey guys, we're back again. We're going to do lesson 10-2 once again, solving linear equations, special cases linear equations. This is day 2. Same thing we did last week, but these are just going to be a little bit harder problems. So again, go ahead and mark up the learning targets. Anything I write down, make sure you write down in your guided notes so you can get full credit for the day. Today we're going to be solving equations and identifying the number of solutions that each equation has. Now remember, there are 3 different types of equations or different types of solutions that you can have to an equation. An equation that has no solution, it has no solution if there is no value for which the variable makes a true mathematical statement. There's no solution for that. If an equation has infinitely many solutions, then there are an unlimited number of values for which that variable can make a true mathematical statement. No solution, infinite solution, and then of course we know typically there's always one solution to an equation. But these are our 2 special cases here. So again, these are 3 different examples of the different kind of equations that there are. So this first equation over here to the right is what we have no solution. Please write that down in your paper so you can recall that this is an example of an equation that has no solution to it. We know this is no solution because 5 does not equal to negative 35. You might also see this, and I'll give you some other examples like 1/2 is equal to 10. We know that that's not true, so that has no solution. If you solve an equation, you end up with something, I don't know, like 5.5 is equal to -2. That is also an example of an equation that has no solution. So whenever you get to 2 numbers that do not equal to each other, that is no solution. This is what we typically see in algebra, an equation with one solution to it. So here we have 3/2 is equal to x. That is one solution. You might also see something where like x is equal to 1.5 or possibly x is equal to 1 3/5. These are all examples of an equation that has one solution. And then finally over here, we have infinite solutions, which means any number that you plug in for x can be a solution to this equation. So here we have -4 is equal to -4. Well, that's true every time, and no matter what value we plug in, it's going to be true. So you could also get something like 2x is equal to 2x. Or you could have something like 5x plus 1 is equal to 5x plus 1. All these are examples of equations that have infinite solutions. So let's look at a couple examples here. Let's go ahead and solve this first one. So I'll do all the A's and then you'll press pause and you'll do all the B's. So on this first equation here, we're going to do the distributive property. 2 times x gives you 2x. 2 times 1, don't forget to distribute there, is equal to 2. Now on this right side, notice we have like terms that we need to combine. 3x and -x. When you combine those, you get 2x. And then just bring this plus 2 down. And what you'll notice here, both sides of this equation have the same thing. 2x plus 2 is equal to 2x plus 2. Right there, we can already know that this is going to have infinite solutions to it. But if we wanted to go ahead and solve out that a little bit further, what you would see was that even if you subtract 2x to both sides, you subtract 2x over here, then what you're going to be left with is 2 is equal to 2. And again, that is infinite solutions. Press pause and do 1B on your own. For number 2, what we're going to do first to solve this equation is we're first going to combine like terms on the left side here. So what you'll see then now is we have, let's see, -2x plus 3 is equal to, over here we need to distribute, so I'm going to distribute -2 times x and -2 times -2. So when we do that, we get -2x, -2 times -2, two negatives make it a +4 plus 3. All right. So now what you're going to notice here is that we need to combine these like terms. So we have a plus 4 and a plus 3. So I'll just rewrite this. Negative 2x plus 3 is equal to negative 2x plus 7. So we have a negative 2x on both sides of the equations here. We could pretty quickly just cancel those off and notice that those both are they're on both sides, so we can cancel those. Or what we can also do is we can go ahead and, if you want to solve it further, you can add 2x to both sides to get the x's on only one side of the equation. And then we will have those cancel, so those are gone. Like I said, those cancel. Whenever on the both sides of the equation, they're going to cancel, and then you're going to be left with 3. Whoa, let me erase that. 3 is equal to 7, which we know is not true, so that has no solution. That is an equation that has no solution. Press pause and do 2b on your own. And then finally, number 3. Number 3 is a tough one. If you can do number 3, A and 3B, you should be set and get 100% on this upcoming test that we have. So for number 3A, we're first going to distribute over here, and then we're going to distribute also over here. So first, we're going to have 1/3 times 2. Sorry, that's going to be 2/3 x minus 1/3 times 4. That's going to be 4/3 plus 5 is going to be equal to, on the other side, we have negative 2/3 x, and that's going to be minus 2/3. I'm going to go ahead and combine like terms. Notice we have numbers on the left side of the equation that we need to go ahead and combine. So over here, let's see, negative 4. So this really ends up being 5 minus 4/3. Whenever we subtract, we have to have a common denominator. So we're going to change this then to be, I'll multiply this times 3, multiply this times 3. So we end up getting, let's see, that'll be 15/3 minus 4/3. So that's going to equal then 11/3 is what we get here. So I'll write that in. So let's see, 2/3 x minus, or sorry, it's going to be plus 11/3 equals to negative 2/3 x minus 2/3. Okay, so now we have variables on both sides, so I'm going to go ahead and add 2/3 to the right. Draw my balance line here so you can see, and then add 2/3 over here to the left. Sorry, 2/3 x to the left. I want to get my x on only one side. So, let's see, 2/3 plus 2/3. Well, that already has a common denominator, so it's 4/3 x plus 11/3 is equal to, well, those cancel out. Those are gone. I'll go ahead and get my yellow here and cancel those out because those cross off. And then we just have negative 2/3. Okay. We're going to subtract 11/3 to the left, subtract 11/3 to the right. Luckily, this already has common denominator. So what we'll do now is those cancel out. So I just have 4/3 x is equal to, let's see, negative 13. Negative 13/3. To get rid of this fraction with the x, we have to multiply by the reciprocal. So I'll multiply by 3/4. Do the same thing to the other side. 3/4. Those would just cancel out. It would just be x is equal to, we know it's going to be a negative. Let's see, 13 times 3, that's 39. And then 3 times 4, that's 12. But hold on, we can reduce this down. Let's divide both sides by, let's see, 3 goes into both. So we divide both sides by down. Our final answer, this is a long problem, is equal to negative 13/4. Like I said, if you can do this problem, you're going to be solid on any problem that comes your way. Press pause and give number 3B, which is a little bit easier, 3B, your own shot. When you get done with 3B, please go on and do the iExcel lesson that's listed in your Canvas account. Make sure you get up to at least an 85 to get full credit on that iExcel lesson.